Hi, my name is Coulter Etheridge, and this is my final project for my stochastic models for CE class, where I will analyze the variability of a numerical continuous variable. I chose to analyze the voltage variance of a single Duracell D14 battery using a sample size of 30 unused batteries manufactured within the past 4 years to hopefully get an accurate representation of the population of these recently manufactured batteries. Here's the procedure. Read the voltage of the randomly selected batteries one by one using a commercial clamp meter with a readability of at least 1/10 of a volt with an uncertainty of 3/100 of a volt. Set the meter to read volts and direct current and remove probe covers. Connect the red positive probe to the positive end of the battery and the black negative to the negative. Make solid contact to increase the surface area in contact and remain still for a second to get an accurate reading. Get the next battery without replacement. Here's the data collected. It was difficult to get this data randomly as I only had 30 batteries all purchased in the Metroplex, but most batteries had 1.5 volts as advertised. And here you see 3 data points that may be considered outliers. I omitted the farthest left point, but considered all other points for my data as 2 points out of only 30 as significant. Next, I check for assumptions. The distribution is more discrete and more skewed. P is so small with a relatively small sample size that the distribution is not expected to be normal nor have a linear relationship. Also, the data is not from multiple groups nor is it dependent. I started my calculations with the mean, which I calculated to be 1.5 volts as advertised despite my skewed data towards slightly higher readings. I then determined one standard deviation is 1/10 of a volt. Next, I needed to find my confidence interval, which required a t-value. Using a t-value chart and finding my degrees of freedom to be 28, and using the 95% confidence level, my t-value was 2 and 48 thousandths. The next step was to plug my calculated values into the confidence interval formula to find the range of 1 and 5/10 to 1 and 6/10 volts. In all, according to the sample data, the average voltage of a Duracell D14 battery produced after 2020 is 1.5 volts. From a 95% confidence interval, we can assume that 95 out of 100 representative batteries have a minimum voltage of 1 and 5/10 volts and a maximum of 1 and 6/10 volts. In retrospect, I have a few recommendations. To make sure the data complied with the assumptions, I should have had a larger sample number to increase the population proportion to have a more accurate data analysis. I also recommend using a meter capable of reading 100th of a volt in order to increase the precision of the data and to get a more detailed bell curve analysis. Additionally, finding a larger source of batteries to select from to increase the representation and randomness of the sample would benefit more accurate data and potentially comparable data. Thank you.